Bangladesh, hemmed in by India and the Bay of Bengal, is one of the most populous countries in the world. More than 122 million people live in an area only 4 times as large as that of the Netherlands. Bangladesh is also among the poorest nations, despite the country's agricultural fertility. The huge rural population plants rice and jute and supports itself by fishing. The infrastructure in Bangladesh is insufficient. The great floods of 1988 and a cyclone in 1991 were very damaging to the country. The Brahmaputra, Padma and Ganges rivers meet in Bangladesh, causing much of the flooding. The Jamuna River forms the lower reaches of the Brahmaputra, cutting Bangladesh in half. In terms of water discharge capacity, this river is the 4th largest in the world. For sediment transport, it is the 2nd largest. It is an untamed, braided river whose bed and main channel are constantly changing. If anything, the Jamuna is whimsical. Depending on the season, its width varies from 5 to 15 kilometers, with a depth ranging from less than 2 to more than 20 meters. The Bangladeshi use ferries to transport goods and people from east to west and vice versa. Ferries are the only means of transport for crossing the river. The waiting times are often very long and sometimes mount up to days. The government has therefore decided to build a bridge across the Jamuna River with the help of international donor agencies. The bridge will make it easier to reach the western part of Bangladesh and the hinterland of India. It will enable the country to further develop economically and socially. Rendell, Palmer and Tritton, Nadeco and Bangladesh Consultants Limited are responsible for the design of the nearly 5-kilometer long bridge. Besides its 2 lanes, the bridge will have a railway. The Korean construction firm Hyundai will be in charge of building the bridge that is so vital for Bangladesh. Nearly half the project costs will go into the river training works, fixing the embankments at the bridge location. The contract for this was awarded to a joint venture between the Dutch companies Ham, Dredging and Marine Contractors, and Van Oord ACZ. Coordination at the first phase of the project takes place from the main office of the joint venture's head office in Dhaka.
You mind if I take this home?
Construction of the initial base camp quickly gets underway, some 20 minutes drive from the actual work site. The joint venture personnel will stay in these porta cabins during the first year. Electricity, sewage and running water have to be specially installed, since such facilities are not readily available in this part of Bangladesh. Nor are there any telephone lines in the region, an essential tool for organizing the work properly. Here too, solutions are found. The official go-ahead for the project was given in March 1994. A 6-month mobilization period was required for commissioning vessels and so forth, and the official commencement ceremony took place on the 16th of October 1994. The principal Jamuna Multipurpose Bridge Authority invited some 3,000 people to attend the event. The politicians, the press, and Bangladesh television are well represented. It is an important moment given the long delay in giving the actual go-ahead and the fact that the public had begun to have doubts as to whether the bridge would ever be built. The then Honourable Minister of Communications, Uli Ahmed, is responsible for the implementation of the Jamuna Bridge. After addressing the guests, the official opening ceremony takes place. The cutter suction dredger Ham 219 plays a leading role in this. The excavation equipment goes to work. The building of Jamuna Bridge gets underway. First, the cutter suction dredger commences dredging activities in the work harbour along the east bank. This will soon serve as a base for various items of equipment. The dredged material will be used to raise the level of the flood embankment behind the work harbour. Some 4.5 million cubic metres will be placed during the first season. The offices, work sites and permanent living facilities will soon be constructed on this area. The enormous quantities of rock required for the project will also be stored here. After dredging of the work harbour, the riverbank will be protected from the rising water. The so-called fascine mattresses are used for this purpose. A fascine mattress is made of a polypropylene fabric fixed to a bamboo frame. Small, portable sewing machines are used to sew the rolls of fabric to a width of 30 metres for the work harbour. Large bamboo stalks are split to make the bamboo fascines. The bamboo sections are tied together and the fascine bundles are then fastened to the fabric as a frame. As agreed with the Bangladesh government, local people are employed wherever possible. The local economy will benefit from this. On average, some 2,500 Bangladeshis are employed. The mattresses can now be towed to their final position in the harbour. The work harbour is approximately 4 metres deep during low tide and 11 metres during the highest water level in the rainy season. The top section of the mattress is pulled onto the slope. The section with the bamboo frame is sunk by ballasting with stones. The polypropylene fabric that sticks out of the water on the slope is covered with river boulders to the level of the verge. The area above will be covered with a layer of open stone asphalt. Many river boulders are needed, a total of 130,000 tonnes for the entire project. The boulders come from the riverbeds in the northeast of Bangladesh. A resounding 40% of the joint venture's budget goes into the provision of boulders and rock armour. Unfortunately, only the boulders come from Bangladesh. The rest of the rock has to come from quarries in India, Bhutan and Indonesia. A total of 1.5 million tonnes of rock will be used. Most of it will be used in the large guide bunds built on both sides of the river. Getting those 1.5 million tonnes of rock into the heartland of Bangladesh is a major logistical problem. More than 800,000 tonnes of rock come from various quarries in India. Unlike most countries, stone cutting is still done by hand in northern India. The joint venture employs Asian supervisors who monitor quality and production planning on the spot. In addition, there are regular visits to the quarries by project staff members to make sure that the delivery targets are met. The transport of rock to Bangladesh is extremely complex. Part of the rock goes by rail. Each train carries around 1,600 tonnes of stone. However, India's railways do not have enough trains. There are only 4 to 10 available per month. The trains go to the Bangladesh border. There, the rock is transferred to Bangladesh trains, which then transport the rock to the west bank of the Jamuna, near Siranjganj. The rest of the rock from the northern India quarries comes by truck. Not without problems, since the border crossing with Bangladesh entails long delays. These countries have a different way of doing things. Waiting times of several days are not unusual here. At this time, the border is closed for a religious festival. When the trucks finally pass the border, they will have to be unloaded several kilometers down the road. The Indian trucks have not received permission to travel inland. The Bangladeshis want to handle the transport themselves so they can earn their share. The Bangladesh trucks transport the rock to the West Bank, where they are loaded on local country boats and finally reach the destination on the other side of the work harbour. A rock weighing some 60 kilos again goes from hand to head. The largest quarry in Asia is the Karimun quarry in Indonesia. Here, some 250,000 tons of rock are produced for the Jamuna project. Fragmentation takes place in this quarry using drilling equipment and dynamite. To transport the stones through the Bay of Bengal to Bangladesh, the joint venture had special barges built in Singapore. Between 5,000 and 6,000 tons of rock are shipped per trip. In Bangladesh, the barges were towed up the river to Chandpur. In the middle of the river, there is a transfer pontoon. Here, the rock is transferred to smaller river barges, specially built by the joint venture for this project. The joint venture also required push boats to bring the river barges in pairs to the project site. Cumbersome, but necessary. The large barges from Indonesia and from Visakhapatnam, India, have too much draft for the Jamuna River. Depending on the river's water level, the smaller barges each carry between 1,600 and 2,400 tons of rock. The push boats cover the final 200 kilometers in 2 days. The convoys cannot sail back and forth carelessly. The river is full of hidden sandbanks, so the only safe way to sail is with the use of advanced computer-controlled equipment. As if this was not enough, the joint venture's survey department is constantly sounding the depth of the river. This is necessary since the depth is continuously changing. The results are determining the specific sailing routes of the push boats. Water injection dredging is used to deepen some sections of the river. Especially for this purpose, a dredging unit has been stationed for the sole purpose of maintaining the river. The ship gets the sounding data from the survey boat and enters this in its own computer. Thereafter, the vessel dredges the river according to the required specifications. The survey vessel checks the dredging work again. To make sure that the rock transport can go safely and uninterrupted, it requires continuous supervision. When the push boats arrive at the work harbour, the loaders and dump trucks are ready to bring the rock to the depot. Once the barges have been unloaded and the push boats have taken on provisions, they return to get another load. The transport will take more than 18 months. The stock of rock must be constantly replenished so that work can continue. Before the rock reaches its final position, it would have been handled 8 to 10 times. Simultaneously, with the construction of the work harbour, the asphalt plant is made operational. The first major job for the asphalt plant is to produce nearly 10,000 tons of asphalt sand. This sand asphalt is necessary for the construction of the shore protection in Burapur, 8 kilometers north of the bridge site along the east bank of the Jamuna River. The shore protection is vital because it will deflect the river currents upstream of the future bridge to flow between the new embankments. First, large quantities of sand have to be removed. Here too, the local population is hired to do part of the work. The Bangladeshis do all the work manually. No one disturbs the small piles of sand. It is a method of measuring how much sand has been removed per team. On projects in Bangladesh, people are paid according to the amount of sand they remove. The available time is limited. Modern equipment is also used in the excavation process to meet the planning. The shore protection here is constructed with mattresses composed of 2 kinds of polypropylene geofabric. The cells result from the way in which the layers are stitched together. The cells are then filled with sand asphalt. The top layers of the mattresses are green. They protect the fabric against ultraviolet light. The mattresses will soon have to prevent erosion caused by currents along the shoreline. During the monsoon season, the water rises to 14 meters above PWD, the local reference level. The residents of these houses have to relocate their homes to drier ground nearly every monsoon. The mattresses are laid along a length of around 1.5 kilometers. The shore protection covers a total area of about 300,000 square meters. Soon, the mattresses will be covered with sand. A black polypropylene fabric will go on the slope. Then the stones will be laid. Afterwards, the open stone asphalt provides the finishing touch on the higher areas. The shore protection will have to be ready within 3 months. May is the start of the monsoon season. The water will rise. A half year later, after the rainy season, we see the water receding. The mattresses bend from the presence of erosion, providing a defense against the current at greater depths. In October 1995, after the monsoon season, the second construction season gets underway. All expatriate project staff are still living at the base camp. Work on the new camp is proceeding well. The new camp is behind the working harbour. It is part of the contract and will be handed over to the employer when the work is completed. When the bridge is completed, the Bangladeshis will live in these houses. There are a total of 63 houses, 60 studios and 2 buildings with dormitories. There will also be a clinic, sick bay, a restaurant, bars, squash and tennis courts, a library, a basketball court and a swimming pool. Meanwhile, there are 4 cutter suction dredgers employed. The dredgers excavate a trench for the guide bund construction in order to place the fascine mattresses and to dump the rock armour from the scar protection. The Ham 219, with which the project started. The Yokra, the Zeeland, and the Ham 250. The Korean company Hyundai now starts driving the approximately 80-meter-long piles for the bridge piers. This exceptional length is necessary due to the poor bearing capacity of the subsoil and because of the risk of earthquakes in the region. They start on the east bank, where the bridge end was fixed in October of 1994. In turn, the joint venture starts building the West Guide Bund, since that is the bridge location which was fixed in October of 1995. The West Guide Bund has to be finished before the start of the 1996 monsoon season, since it is lying on a vulnerable sandbank known locally as a char, right in the middle of the river. Also, the land between the West Bank and the future West Guide Bund has to be raised. This is in order to assure that the water will go between the two guide bunds. This raised land area doubles as the access for the bridge road and future rail transport. Each guide bund is a good 3 kilometers long. Until now, all activities have taken place on the East Bank. The work will now become more complex and troublesome because the workers and equipment will first have to be shipped to the West Bank. Facilities will also have to be built on that site. Besides offices, first aid post and a canteen, a workshop will be reacted for the maintenance of the equipment. There is now a workshop on both banks. With the assistance of local staff, expatriate engineers carry out maintenance on more than 50 pieces of equipment. There are some 60 Land Rovers for transporting personnel. A special garage has been set up to maintain this fleet of vehicles. Typical of the untamed, twisting Jamuna River are the many tributaries and channels that have formed over the years. On the West Bank, there are 3 major ones that must be closed. This too will require rock. Now, the cutter suction dredgers will fill the channel with sand. The large dredgers cut the sand. Pipelines carry the sand kilometers further along the channels. The job will require a great length of pipeline. More than 13 kilometers of pipe will be used. Meanwhile, work continues on the construction of the West Guide Bank. To make underwater slopes, the dredged sand is used for raising the guide bund. Hydraulic excavators, loaders, and articulated dump trucks are used for finishing the upper sector of the slope. During this second season, some 17 million cubic meters of sand will be dredged. After several months, the guide bund has assumed its desired shape. Immediately after finishing the trimming of the sand slopes, they must be covered above and below water with geotextile, rock, and again, stone asphalt. The fascine mattresses being made here have a total length of around 130 meters. The height difference of the slope is over 30 meters. Again, geotextile with bamboo frames are used. When they are completed, the fascine mattresses are towed to their final position. First, they are anchored with concrete blocks to the upper slope. With the help of the sinking pontoon, Vianen, the fascine mattress is then lowered in place. Here too, the fascine mattress is sunk using river boulders. Later, blasted rock will be dumped for further cover. Large rocks are dumped underwater at the foot of the slope. They provide extra protection in case of toe erosion, the so-called falling apron. With this special ship, the sidestone dumping vessel Pompeii, the rock is dumped in its final position. The vessel is fitted out with much advanced equipment, like a dynamic positioning system fed by satellite positioning. The computers calculate exactly where the rock has to be dumped. Rock up to 115 kilos is placed at the falling apron. Rock up to 100 kilograms is used for the slope protection and is also used for the slope to 100 meters on both sides of the bridge's axis. When the Pompeii has dumped its rock, the survey department comes into action again. The survey boat measures the layer of rock placed and checks to see whether it meets the specification. Afterwards, the survey department discusses with the crew of the Pompeii whether and where the layer thickness increase. The next trip is made with the new computer data of the survey department on board. Meanwhile, above water, the rest of the slopes are finished. First, the slope is covered with geotextile. With plant and manpower, the rocks weighing up to 60 kilos are put in place. The top slope gets a layer of open stone asphalt. The asphalt plant operates at full capacity to get this job done. A complexity factor here is the transport to the West Bank. To place the open stone asphalt properly, the mixture is not allowed to cool down quickly. Since the ambient temperature is around 38 degrees centigrade, there are no problems. The dump trucks are ready to bring the asphalt quickly to its destination. A final temperature check is made, after which the material can be applied. Besides the open stone asphalt grouting, mortar is also used. The material is poured across joints between the open stone asphalt and the rocks. The construction of the guide bund must be done quickly now. Very soon, the water will rise and the work must be finished. In several months, when this monsoon season has ended, construction of the East Guide Bund will begin. Until then, the joint venture will concentrate mainly on preparing the work for the third season. This will not affect the supply of stones from the Asian region. It will continue undiminished.